You already know how to find the inverse of a linear function, and you know that when you do that, its inverse is also a function, but this isn't true for every function. In the warm-up, you saw that when you graph the inverse of a quadratic, that its inverse is not a function. But it's important to realize that a piece of it is. And this piece of it is the square root function. And when we analyze it, we can learn a lot. What we're going to explore today is what are some properties and uses of the square root function?
Want to talk about quadratic functions?
What about them?
You might think that if you flip the graph of a quadratic function over, you'd get a function.
Yeah?
But that's not the case. Let's look at a graph of a quadratic function to see what I mean.
Okay.
Okay, so the parabola here is split into two parts, a blue one and an orange one. The blue part is where all the x values are greater than or equal to 0, and the orange part is where all the x values are less than or equal to 0.
All right. So when we graph the inverse, it isn't a function because it doesn't pass the vertical line test. But the blue and orange pieces, when looked at separately, are each a function.
You got it. And when we talk about square root functions, we're actually talking about these two pieces. But we usually focus on the blue piece, where x and y values are both positive.
Got it. But what if we want to find the inverse without using a graph?
Good question. Let's say we have f of x equals x squared. To find the inverse, we first write the original function in terms of x and y. That means we replace f of x with y to get y equals x squared. Then we swap x and y to get x equals y squared. To solve for y, we take the square root of x, which gives us y equals the positive or negative square root of x.
Yeah, so that gives us two parts again, right? The positive square root of x, which is the blue piece, and the negative square root of x, which is the orange piece.
Exactly. But remember, when we talk about square root functions, we usually mean the blue piece, the principal square root function. Each piece is a function on its own, but the inverse as a whole is not.
Wow, that makes sense. Thanks.
Yep.
So here's another example where we're asked to find the inverse of a quadratic function, but this one's a little bit different. We're going to use the completing the square method to help us find the inverse of this function algebraically. So say we're given the function f of x equals x squared plus 6x, where our domain is restricted to all values of x that are greater than or equal to negative 3. And then this is an important restriction, and we'll see why later. So the first step is rewrite your function in terms of x and y. So we have y equals x squared plus 6x. What we're going to do is complete the square now, and then we'll interchange our x and our y values. So in order to do that, you take your b term, which is positive 6 in this case, divided by 2. You get positive 3, and positive 3 squared is 9. So I'm going to add 9 to both sides of my quadratic. Plus 9 plus 9. I'll just rewrite it. Y plus 9 equals, now this is a perfect square trinomial, so I'm going to write it in factored form, x plus 3 squared. Now I'm ready to interchange the x and the y values. X plus 9 equals y plus 3 squared, and we just have to now solve the function in terms of, or is it a function? We'll see, in terms of y. Take the square root of both sides. Y plus 3 equals plus or minus the square root of x plus 9. We subtract 3 from both sides, and we get y equals plus or minus the square root of x plus 9 minus 3. This is the inverse of our given function. And it's important to note that it is also a function because of that restricted domain. Because x is only values that are greater than or equal to -3, you'll see that when you graph this, that it will pass the vertical line test. And you'll see for every value of x, there is only one unique corresponding value of y. In this lesson, you've discovered the significance of the square root function. Now that you've learned how to identify the principal square root, let's examine some of its properties. What are some properties and uses of the square root function? Let's take a minute to make some observations about the domain of a square root function. When we talk about domain, we mean the x values, the amount or the number that you substitute into the equation, your input, in order to give you an output, your y value. The domain so far has been all real numbers. Have you asked yourself why this is, though? What would happen if we substituted in negative x values? Why does the graph not lie in the second quadrant? Well, what would happen if you did? If you substituted a negative x value into this particular function, y equals the square root of x, you'd have a negative under the radical, and you can't take the square root of a negative number. So this is why our domain is restricted, because if you take the square root of a negative number, you won't get a real number as your output.